When we say, what does geoengineering mean? This would be the first time we consciously decide to globally affect climate to our benefit.
Engineering on purpose.
Right.
Yeah.
You're talking about the radiation that's coming in and greenhouse gas is trapped. It literally becomes kind of a
Chuck,
bounce board.
It's called science.
Yeah, it's so cool, isn't it? It's pretty cool.
This is StarTalk. Neil deGrasse Tyson here, your personal astrophysicist, and this is special edition. And we're going to be talking about geoengineering. Ooh. Gary, you cooked this up.
Yes.
My co-host Gary here. How you doing, man?
I'm good.
All right, you're looking in good shape.
Breathing in, as we've discussed.
Breathing in.
It's the breathing out I'm not doing.
That's all right. Chuck,
Yes and no.
welcome back as my co-host.
Always a
okay.
pleasure.
All right. So Gary, what did you
What do
set
we
up
got?
today?
All right, so the annual Isaac Asimov Memorial Debate takes place here in the Hayden Planetarium, and this year, in 2025, it is geoengineering, the pros and the cons. Seen by many as controversial, it's an approach to solving global warming, but there are others see it as potential as very, very effective. There are a number of different options up for consideration, but with them come not just scientific issues, but ethical considerations as well. So pre-debate, we kidnapped two of the panelists, and we've dragged them, locked them in the office, and we're going to have our own debate because we couldn't wait until this evening. So
Did they come willingly?
Help.
He's still in a box. Who do we have here? Daniele Visioni. Daniele, welcome to StarTalk.
Thank you, Neil. Thank you for
Yeah, let
having
me
me.
get a little bit of your bio here. Assistant professor in the Department of Earth and Atmospheric Science at Cornell. Thanks for coming downstate to join us here. Is it still snowing in Cornell? It snows there all the time.
Yes, it is. Yes, it does.
Yes. It is and it does.
Yeah.
We good.
All right.
You're a climate scientist specializing in this cottage industry of people who care about stratospheric aerosols and their behavior.
Ooh.
Whether they misbehave or behave as you intend. That's your whole...
Well, let's find out.
Yeah.
And you're also a specialist in what they're calling climate intervention methods and what its impact would be on the climate, on ecosystems, and even on culture, societies. So, I mean, that's a very high responsibility.
Yeah, it is.
In other words, don't mess up.
Yeah.
If I were over there,
A lot of people lining
I'd
up
grab
to-
your lapel and say, don't mess this up. So who had the idea that this is a thing that would work?
People have been discussing it for decades. I would say some people point to Edward Teller actually being the first one discussing.
Teller of the
Yep.
H-bomb fame.
Yes, indeed.
Or infamy.
Right. People had discussion about could we fundamentally, deliberately alter climate for a long time, right? For as long as we understood what climate was.
machine, I will
Right?
one day rule the world.
Yeah, no, indeed. So it is in a way, one could say nothing new, except then as the problem of global warming, of climate change became more and more prominent, more and more scientists started thinking about this maybe a bit more deeply.
So it wasn't just a fringe idea.
It was a fringe idea in the sense that a lot of people,
No, initially, but now
Right.
it's no longer fringe.
many would still consider it fringe, or at least would like not to talk about it too much.
Oh,
Yeah.
that's different. Okay.
Right? In that fringe, in that sense, I would say that the scientific basis is as well established as for most of climate science, but the most of the issues being in sort of the ethical, societal dimension bring this topic into a different light.
So as I understood from my bit of reading here, you had some prior awareness and understanding of this problem or the solution with volcanoes.
Indeed.
Because they pump all manner of
Nastiness.
Yeah.
Nastiness
Yeah.
into the
No, you just
atmosphere.
Nasty.
Nastiness.
into the atmosphere, and you get to study that's nature doing it. And so what have you found from the history of volcanoes?
Yeah. So the interesting thing is that it was Benjamin Franklin,
My man,
one of
Ben.
the first.
Everybody loves Ben.
Yeah.
And he was a great scientist too. He was the first person to point out that potentially the weirdness in climate that people had seen in the early 19th century were due to the Tambora eruption, a volcano in Indonesia, exploding in 1815.
Okay. So he's around, of course, at that time. Just remind me, I think Indonesia also has Krakatoa. I mean, there's no shortage of volcanic
There's plenty of volcanoes in the tropical band. Yes, close to the equator. And sometimes they just go off, they explode.
Yeah.
Yes.
And you get to see which way the ejecta goes. Like it goes west to east, right? Following prevailing air currents.
Yes.
So people get to study this. And he was clever enough to connect the dots
Right.
between odd weather and an odd atmospheric phenomenon of volcano.
Yes.
Okay, so this is some of your foundational background for how you go forward from that?
Yes. In the 20th century, then, there were at least 3 different volcanic eruptions, not as big as Tambora, but still big enough, the last one being Pinatubo in 1991. And
I was observing at a telescope, and when Pinatubo went off, it changed the optical properties of the atmosphere. We had to redo all of our data. Pissed me off.
It's not all about you.
Not your favorite volcano, I assume.
Because I was at the telescope when the stuff came by.
Right.
Not when it went off, but it took a while. It took a while.
So
to get around.
once again, scientists taking their cue from Mother Nature. And I don't mean that sarcastically, it's a fact.
No, it's straight, yes.
So with putting, it's sulfate aerosols?
Tell me what is an aerosol?
Okay, so by aerosol, us climate scientists define just every kind of solid or liquid particle suspended in air, but
so
very
it's
tiny.
the suspended part that makes it an aerosol.
Yes, the suspended part, yes.
Yes, okay. The fact that it can be suspended at all makes it an aerosol no matter what it is.
Like SARS-CoV-2.
You see, that's a very interesting
Believe
thing.
it or not.
There were a lot of discussion about what constituted an aerosol when it came to the discussion around COVID, because there were different definitions between what climate scientists consider an aerosol, these very tiny particles, sub-micron scale, they float around for a long while.
I mean,
and
micron
the droplets.
is a millionth of a meter, so very small.
Very small, so gravity doesn't really do much. Turbulence actually keeps them afloat. And the very large droplets, like the one, like spit, that medical practitioners consider aerosols, right?
Well.
So these was a lot of the confusion at the beginning around airborne.
2 slightly different usages of the term.
Of the same term.
Same term.
Yeah.
To get to reducing mean temperatures here on Earth, what science do those aerosols have to
By
perform?
mean temperatures, you mean average?
Mean.
These are the temperatures
nasty.
that make fun of the lower temperatures. They're mean temperatures.
They're pissed off temperatures.
There you go.
Okay.
Yeah.
Go.
So the aerosols we think about, again, submicron scale, that's ends up being the same size of the wavelength of most of the visible light that we get.
Oh.
So they are at the specific size where they really interact a lot with incoming sunlight.
That's wild.
So it's photochemical.
It's actual more
It's
like
physical.
geometrical.
It's
physical.
a physical block.
There's also
Yeah.
some chemistry, but mainly all of the aerosols that are around that size will interact with solar radiation through Mie scattering, through various scattering processes, and
Remind me, Mie
reflect
scattering, that's MIE scattering. So that's a simple scattering where the wavelength of the light matches the particle.
Right.
And then it redirects it.
Bounces off.
Because it goes off.
Yeah.
But we have, like, Rayleigh scattering is a different kind of scattering that gives us the blue sky.
The blue sky. That's
And
for
we
much
did a whole
smaller.
episode
That's
on
for
that.
light. Yes.
Yeah.
That was
Okay.
great.
Yeah.
By the way, that makes so much sense because you're talking about the radiation that's coming in, and greenhouse gases, primarily carbon, is trapped. Carbon dioxide, sorry, is trapped because when the ground radiates heat, it's the atmosphere that's trapping a different wavelength.
Correct. Completely different.
Right.
Yep.
So
infrared. specifically.
Infrareds, right. So that's so wild.
Yep.
It literally becomes kind of a bounce board.
It's called science.
Yeah, it's so cool, isn't it? It's pretty cool.
How about that?
I'm just saying.
Oh my God.
You can still call it wild, but at the end of the day, it's science.
So for this process to be successful to the level that we would all want it to be successful, how much aerosols do you have to put into the stratosphere? How long is it there? I mean, who gets to argue over where you put them? Does it matter then on seasonality?
And what have we learned from volcanoes about where it goes?
Right.
And if I remember correctly, I think it was the late 80s where there was talk of nuclear winter, where a total nuclear exchange would burn forest, put, I guess, aerosols in the atmosphere, blocking sunlight, plunging all the Earth into
darkness and cold.
Into cold.
Yeah.
So that would be a bad effect of it, but now you're trying to make it a good effect.
So let me. All great questions,
Yeah, that
but
was a
they can
lot. That was
all
a
and it
lot
can
of
also all
questions.
be connected, right? So aerosols, we already have aerosols all around us, right?
Okay.
Most of the pollution, the haze that you see in New York City, that's pollution. Those are aerosols, right?
But it makes
And
for a
they-
lovely sunset. Let's
Right.
be for real.
Makes a lovely sunset. It's super bad for your health.
Right.
When you burn fossil fuels, you burn coal, you produce these aerosols that are super bad for your health. And once they
My
rain
emphysema
down,
has never been worse. But it's a beautiful sunset.
Let him finish. I want to hear this. I need to hear this.
Just trying to think.
so they come down, and they come down, mostly we burn them very close to where we live. They stay in the air, but they are below the clouds. So whenever then there's rain, they just get washed
Washed
out.
away. Right.
So actually, currently, we...
Just to be clear, a raindrop forms on these particles and
it
takes it out
absorbs
of the
not as much for sulfate. Sulfate is actually not as good as a cloud nuclei as other kind of particles. Not all aerosol particles.
But when they
make for
say
good
something,
cloud
things
nuclei.
rain out, they typically mean that the droplet formed on these particles?
No, it can also mean that the droplet, while falling, absorbs
Absorbs it.
these
Oh.
tinier particles.
Got it.
That's
Literally
that's
washing
called
them out
wet
of the sky.
deposition or washout of
Washing them
aerosols.
out.
And what's the real term?
Wet deposition
Wet
or
deposition.
washout.
Cool. I love
yeah,
that.
or washout.
I love that.
Yeah. So normally we emit, as humans, just as pollution, over 100 million tons of sulfur dioxide, which is the precursor of all sulfate aerosols, per year. 100 million,
100 million
tons.
tons.
It's a lot. And most of that falls down close to where we live, right?
Yeah.
Acid rain, people who are alive in the 80s, not me, but people who are alive in the 80s will remember acid rain. That were because
Wait,
before...
just so I get my chemistry, remember my
Yeah.
chemistry. Sulfur dioxide is not itself acid, but if you combine with a hydrogen, you get hydrogen H2SO4,
Yes.
which is itself sulfuric acid.
Yes, so-
and that would be the acid rain.
SO2 gets oxidized by OH, the radical OH, which is present everywhere in the atmosphere. And these then eventually results another 3 reactions and results SO3 and then H2SO4.
Gotcha.
And then this H2SO4, it's in vapor form, sulfuric acid, and then tends to nucleate into sulfuric acid particles, liquid aerosol
Hence
droplets.
acid rain.
Yep, hence acid rain. So back in the 80s, the US was emitting way more sulfur than it is now. And so the global emissions were 160 million, 150 million tons. Now the US has been going down for a while, Europe as well, China and India have been going up, but in general, we're still around 100 million tons. These aerosol particles do have a cooling effect. We know this. The IPCC, the Intergovernmental Panel for Climate Change, has known this for a while. They do cover up a small fraction of the warming produced by the greenhouse gases.
What you're saying is our effort to clean up the air has taken these particles out and thereby
Has
increased
unmasked.
the effects of global warming. Unmasked.
It has
Good.
unmasked. Yes.
Unmasked,
Yeah,
very
that's
good.
the word that normally it's used. It has unmasked
Yes.
part of the global warming that before was sort of hidden. So, and this is the other part of the observation, right? But to do this masking close to the surface, you need hundreds of millions of tons because these aerosols stay just a couple of days.
Okay.
So the idea behind something like stratospheric aerosol injection is, what if you could put a tiny fraction of these aerosols that would stay though for 100 times longer than they do at the surface
months, not
before
days.
falling down, right? Months up to a year. Essentially, you would get more bangs for your buck, right? With just a smaller fraction, you would get the same amount of cooling, but far away from where people live and breathe, and you could get the same effect while not pushing
So,
pollution.
so
So
what makes the stratosphere special for how long something would last there? Is it because we're not making clouds there?
Right, so there's no clouds, there's no water vapor. The stratosphere is very dry, so there's no rain out. But also, the troposphere, it's called troposphere because it's turbulent, right? Because there are turbulence.
Troposphere is the lowest
convective-
level. The lowest
The
level.
where we live, right? Where airplanes are. Above the troposphere, there's a stratosphere that is called like that because it's very stratified. There's no turbulence, things move very slowly. So once you
I
put
never thought about that because if you have turbulence, it's turbulence up and down, and if you're up and down turbulence, it's not stratified. So that's why you call it stratosphere.
Yep,
Very
indeed.
good. Thank you.
and so once you put
And in
something
Italian, what is it?
stratosfera. yeah.
I knew it would be a cool word.
Yeah.
Stratosphere.
Well, that's where it comes from, right?
yes. It's the original Latin.
Just yeah.
The original Latin root.
So yeah, once you put something, especially in the tropical stratosphere, that's where there is the large-scale, what we call the Brewer-Dobson circulation. It's essentially this large-scale stratospheric circulation that pushes things up close to the tropics and then pushes them poleward. So eventually, the air that is in the stratosphere goes back down, but close to the pole, and it takes a year and a half before a parcel of air that originates or of any material that is in the stratosphere goes all the way, gets removed from the stratosphere.
Got it. And you get a good spreading of the
Yes,
effect
that too. Because
latitude.
because the other thing is that both on a latitude, but even more importantly, on a longitudinal way, as in once if you put, and this is another one thing that makes stratospheric aerosol injection complex from a political point of view, is that you can't put these aerosols on top of the US and they're not going to stay there. They're going to spread throughout definitely the whole latitudinal band. So China, which is on the same latitude as the US or Europe, these aerosols are going to in a week. So longitudinally, the winds are very fast. And so in a week or two, there's a complete spread. And we see that with volcanoes all the time. Small volcanic plumes spread in a couple of weeks throughout the whole.
That's how I know, because I was in the Chilean Andes, and the Pinatubo was east of us. That just came due west.
Just
and
mess you up.
Mess me up.
So when we had that explosion in Iceland, it brought civil aviation to the ground.
Test him to see if he can pronounce the name of that volcano. What was the name of that volcano in Iceland?
Everybody calls it a I have a lot of volcanologists. They just call it
You got the answer you deserve.
That's the answer I deserve. But that stopped air traffic in and out of Heathrow
Everywhere.
and everywhere in Europe. Yeah.
But that was not the sulfate. Because
Okay, so do we
have
have a potential issue, because you say it's going to sit above this area of commercial air flight, will it not descend?
So two things. So volcanoes explode all the time. And when they explode, the main thing they do, the short-term larger effect, is the ash.
Right.
Yeah.
So that's the thing that is very dangerous for aviation, because when ash interacts with the aircraft, it
Gunks
can
up everything.
Right.
Yeah.
It can glassify, and so it can be a real danger. Some volcanoes.
Did you say glassify?
I think so, and I'm not sure whether that's an actual scientific term, but let's pretend
I
it
love
is.
that. So this is the ash getting heated in the engine,
Right.
turning into
Glass.
glass. But
Something
wasn't
like
it already
glass.
heated in the volcano?
Right, but then it cools down pretty quickly, and so the ash actually forms that way, and then it can sort of undergo.
So the
other
ash is
processes.
pretty okay. So when people get buried in ash, like they did in
Pompeii.
no, Pompeii was not ash. Ercolano was ash.
Okay.
Pompeii was a
Well, just the magma, the
it was
lava.
just
That was a magma flow?
It was actually a mud flow, really.
Oh, that's right. Yeah,
that's why everything
they
was preserved. Right,
That's right.
right.
That's right. It was a mud flow.
Yeah. So I hadn't fully appreciated what the ash was and what it can be at its worst.
Yeah, so this ash is the first thing, the thing you actually see. You don't really see the sulfate, right? But it's a thing that is dangerous over a 1-2 days time scale, a week, right? Also because this ash is also very tiny, and so you can breathe in, it's very dangerous and so on. And it's dangerous for aviation. Some volcanic eruptions also have what for climate scientists is a lot of sulfate. Not all volcanic eruptions also launch sulfate in the atmosphere. For instance, Hunga Tonga, that happened in 2022, was a huge volcanic eruption. There was almost no sulfate. It was just water vapor pushed up from the ocean, but there was almost no sulfate. Hunga Tonga had something like 300,000 tons of sulfate. Pinatubo had 17 million tons of sulfate
okay,
in
there
a
you go.
couple of hours.
And how
All
much
dumped
sulfate
into
does
the stratosphere.
Hakuna Matata have?
I would have to go back and check my numbers. I don't know. Good question.
So we're putting aerosols into the stratosphere, and we've got the natural cycle of the wind systems. How do you discuss this with sovereign nations? And they say, well, I don't want that flying over my territory. Who then owns the territory above a particular country?
Do you have to find your counterpart in every country so that they can speak to their governments to come to an agreement on this?
That's definitely what we do as scientists. Yes. I constantly talk and work with climate scientists from all over the world, for sure. For your question, though, I would say nobody knows who the stratosphere belongs to. The stratosphere, of all places, is actually one of the least regulated. We know airspace is in the troposphere, and so we know who's liable for things that happen in the troposphere, and then there's space and some other treaties regulating that. But nobody really had to regulate the stratosphere for a long time. The only treaty that exists is the Montreal Protocol for substances that affect stratospheric ozone, which protects us from damaging ultraviolet light.
But that whole protocol was just for the ozone.
Just for the ozone.
It was just for the
ozone,
ozone,
yeah.
and a couple of years ago, there was an increase in one of these ozone-depleting substances that was not predicted, was not expected, and it took countries a year to figure out from which country this increasing depleting substance was coming from. But even then, the
Don't
Montreal
leave us
Protocols...
hanging. Which country was it?
Well, it was a country in Asia.
Okay.
Okay. Even you see, interesting thing was that the agency, the U.S. scientific agency that found out about where this product was coming from, couldn't just point the finger and say this is coming from you, right? They could say we think that this increase is coming from this region of the world.
Okay.
But there is no enforcement mechanism, even in the Montreal Protocol, that could say, oh, you have to stop. I mean, the country voluntarily agreed to stop, right? So a lot of these international treaties don't really have enforcement mechanisms. For the Montreal Protocol, it's all a matter of all countries agreeing that ozone is important and it should be protected.
I think more countries signed that than any other treaty ever.
It is the most successful climate and environmental protection treaty in the world. Yeah, every country signed it because every country realized how important it was to have an ozone layer.
Yeah. So, Chuck, you missed it.
Yeah.
Okay. It was a cosmic phenomenon that affected mostly white people. And so they acted like that.
They acted that quickly.
Yep. That is surprisingly correct. But yeah.
What does it take to motivate
Right.
the powerful countries of the world?
Yeah.
Just say...
Not get their tan. if their tan is at risk.
You're going to lose the beaches.
Yeah.
So what could the stratospheric aerosols achieve?
So, first of all, very clear, these aerosols cannot solve climate change. Climate change is a whole other problem. It comes from the greenhouse gases that we have in the
So it's
atmosphere.
a Band-Aid, as we would say.
It's a Band-Aid. It's a stopgap. You can call it however you want. It's something, some people dismissively say, well, it's like taking an aspirin if you have cancer. It's not treating the underlying causes. But even if you have cancer, you have the right to a dignified life and not to suffer from other pains, right? And so in a way, it's a Band-Aid in the sense that, yes, it could help temperature from going up, right? It could prevent further warming. And this way, it could reduce some of the risks that come from this warming that we know are going to come from this warming and that we are already observing are coming with the warming that we see now.
So a couple of questions, fast ones.
Mm-hmm.
Climate seems to me, even as an astrophysicist, to be an immensely complex problem to solve, given all the variables, given the turbulence in an atmosphere, the gas and different gas species, and the interaction of the atmosphere with the ocean and the land, and all of this. So is AI helping you in any of this?
We're definitely exploring a lot of ways in which AI could help reading the huge amount of data that we already have. For instance, from satellite observation of things like plumes coming out of volcanoes. Nobody could look at all of them, right? That's what AI is very good at. Pattern recognition. Finding stuff that humans would have a hard time with. So this is really an emerging field, but there's a lot of interesting things that we are starting to do with AI
Okay,
as well.
so then here's a risk that I learned about, and I just want to know, is it authentic and is it the worst thing to worry about? If the temperature starts rising and you say, we need more aerosols, and so you got these two competing forces, you get to tamp it down, then there's a terrorist attack on the people putting up the aerosols. Then the aerosol falls out, and now you have a catastrophic shock to the system because the greenhouse gases have been going up.
What you were masking for so long.
You were masking for so long, then it's instantly, you have a catastrophic exposure to greenhouse warming. How much do you think about contingencies here?
That's a great question. And I would say it is something to worry about, except I would say it would not be instantaneous. If you stopped since these aerosols stay for so long, if you stop putting them for a day, a week, a month, nothing really changes because the aerosols stay on for a long time. Now, if you stop for a year or 2 years, that's where you unmask all the warming, right?
You.
So this is your...
So that gives you some time.
You have a cushion.
To find the terrorists.
To find the terrorists.
And kick their ass.
Right.
And rebuild or
and
do
rebuild,
whatever.
okay.
But of course, you would have... I think this is a very valid concern when it comes to stratospheric aerosols. But it's also one that points out to the fact that essentially you would need to plan carefully, have contingency plans, and you could not rely on just one actor doing this, right? Because this is a worldwide thing. Could someone go up and put something? Sure, maybe they could before they were stopped. But that's not how you would achieve anything. To achieve anything, you would need a carefully planned thing with contingency plans for what happens if we need to stop. For instance, I've done research on what would happen if a volcanic eruption happened while you're doing this. What would you do? And well, it turns out that, then you would ramp down or maybe shift where you're putting the aerosols to try to manage
This is true geoengineering. You understand your planet and you interact in a way to your benefit.
Yeah. The key difference is really in the word deliberate. When we say, what does geoengineering mean? And a lot of people ask me, well, haven't we been geoengineering the planet already with all the greenhouse gases? Maybe in a way, but the point of geoengineering, we say deliberate, because this would be the first time we consciously decide to globally affect climate to our benefit.
Engineering
or to
on
somebody's.
purpose.
Yeah.
Now, what about unintended consequences? Because you do something here, something else has to happen over there. So what do you anticipate, or what have you seen?
That's way too polite. How can this go horribly wrong?
There you go.
That is a perfectly fair question.
Because
and
there's things you look that you know could go wrong, and then there are the things you don't know can go wrong.
Right.
Totally.
And for something as catastrophic as Earth's atmosphere, where does your confidence come from?
Our confidence comes from a lot of different observations. The main one being we do have an upper bound for how wrong things can go. And that's, again, Pinatubo. If a volcano can dump 17 or 20 million tons of sulfate all at once
Into the stratosphere.
And things happened after that, right? Temperatures cooled. There were changes in atmospheric chemistry and so on. But fundamentally, that's really as catastrophic as it can get. And we've been able to understand what happened there, right? On top of all of that, all of the sulfate came down, yes, but there's so much more. When we talk about sulfate, the reason we do that is because we understand the environmental impacts. They're not good, for sure, but we understand them. Now, you could be thinking of, what if we try to engineer a perfect compound to put in the stratosphere instead of sulfate? Something that works better, that is not as toxic. You could do that. People are thinking about that. That's legit. But in that case, that's not something that we understand how it interacts with the environment long term, while sulfate is something we understand very well. So I would say
it's the devil you know.
Right.
It's a devil we know. We understand the upper bound of how wrong things
You
can
have
be.
experience with it. You've seen it happen before.
And just to be clear, when the rain comes out, you you can acidify regions that could be harmful to wildlife or plant life.
So again, in these, as opposed to when we do it through pollution, these aerosols would mix very well. And most of that actually would fall, most of the aerosols then would fall over the oceans, where really sulfate is not something that affects ocean acidification that much, because that's mostly carbon driven.
Right.
Again, that's a clear trade-off. You would increase pollution by a little bit, right? 10% more than now in many locations. You would spread it evenly, but it would still come down. And does that have effect? Yes, that's one of the, that's one of the things we definitely are looking into and should be looking into more, actually quantifying and understanding these trade-offs, all the things that could go wrong. And it could very well be that there are other things that could go wrong that we don't know yet, or maybe we haven't thought about, which is why I always welcome other climate scientists starting to look into this field, because if suddenly we found a roadblock, something we hadn't thought about, nobody had thought about in the last 30 years, that would make these, no, look, we really can't do this. This is too dangerous for this reason. Okay, at least we know, right? The point of doing research is that then at least we can say, nope, we've thought about this. Here's the reason why we can't do that.
So I have an analogy from physics where in the Large Hadron Collider, where they're creating energies, where there was some risk that you might create a black hole. A small risk.
So it's a small black hole. Yeah.
That would then consume the Earth as it moved through. And so why do you proceed, even if that's such a small risk? Because that's a small risk, but it's catastrophic to the planet. And it turns out nature gave us examples. There are cosmic rays that come from deep space, like the center of the galaxy, at extremely high energies, higher energy than anything we're making inside the accelerator. And they collide with molecules in our atmosphere, and it's not making black holes.
Making a black hole.
And we've been here for 5 billion years. So
that's the cosmic pinatubo or pinatuba. That's the cosmic peanut butter.
we have nature to calibrate our expectations.
Yeah.
Where are we with the simulations and therefore then testing? Because we can sit here and have a talking shop for decades. It sounds like we have, because I'm part of the team now, obviously.
Right.
But surely this testing goes on, but there must be something pushing back for this not to be the case. Because this sounds too good to be true to, even if it's a Band-Aid, I think we'll take the Band-Aid right now.
Yeah, I think that's part of the issue, right? And I would say I work a lot with social scientists as well, and when it comes to this topic. And one time I was talking to one of my colleagues, and he really asked me the same question. I was like, well, then this sounds good. Why aren't we doing it? And we kind of set out to think about these from a societal perspective, right?
As any good scientist should do. You want to look at all angles, even angles opposite where you're trying to go with it.
Right? Yeah, and it is clear that there are a lot of worries, right? When you talk to people about it, they're like, wow, this sounds crazy. And that's a perfectly good reaction. Now, the question is, when do people stop having that reaction? Will it ever happen? And what is going to take? Some people suggest that once people are going to experience more and more the effects of climate change, that's going to change their mind.
So desperation is what you're
I do not think we should make plans out of desperation.
Okay.
On the other hand, people are saying, well, will there be a point in which we are secure enough into our assessments that this will convince most people, right? I think that's kind of the angle that I try to work with, as in, I think that the main ways in which we're going to have meaningful discussions about this and move forward and maybe start even outdoor testing is once we've put the whole scientific community, in a way, behind assessing robustly what do we know and understand about something like stratospheric aerosol injection. So at this point, there's just, honestly, a handful of scientists compared to the whole climate science endeavor. But the amount of people that are looking into this is getting bigger and bigger. And so I think we're pretty close to having broader international assessments around the topic, which means that, because eventually when I maybe talk to policymakers or to people in other countries, they don't want to know the results of my study or of my climate model run. They want to know what's the agreement, right? So that's kind of why it's so important to talk about this from an international perspective.
The results of any one lab.
You need a geopolitical scientific consensus.
Imagine if they had thought about that with something like the IPCC, the Intergovernmental
really
Panel
what you
on Climate
need.
Change. Indeed,
And once you have that, you might be in a better position
But then
to
when
move.
you get 10 people in a discussion, you end up with 12 opinions.
Of course.
Always the case. But trying to get nations to sit around a table and, well, it's not bothering me, or you're not putting that over my sky.
They're not in my backyard.
So how far are we from making something like this implemented?
I would have absolutely no way to predict that, I would say, and be honest. But I think we can, for instance, look at climate change, right, and say, honestly, the first assessment report from the IPCC was in 1994, was in the early 90s. And we've advanced greatly, but fundamentally conclusions haven't really changed from 1994, which is we add greenhouse gases, that's bad, that increases warming, and that's going to make things worse.
True.
And there have been, I want to take in this case the optimistic view of saying, there have been many advances when it comes to climate change mitigation and policy. Have there been enough? Definitely not. But there have been, right? There have been the Paris Agreement. Now, is the United States of America out of the Paris Agreement? Yes, it is. Will they stay for long? I don't know. But, solar and wind are kind of unstoppable. There's a lot of
At the rate they're going now.
Yeah.
Europe is very much into renewable. China is even more than
Very
Europe
much
and the
more
United
so.
States.
In spite of their carbon footprint growing in some sectors, they're still making great advances.
Yes, they are, because they understand.
They see it as an economic issue. They don't even care right now. They look at it as this is a necessity for our economy, unlike, unfortunately, the supposed greatest economy in the world.
So in this sense, I guess as a scientist, I'm not going to be the one making the decision about whether to do this or not. I shouldn't be. It should be no science. Me and I'm sure Neil as well, we've met enough scientists. We shouldn't be the one making this kind of decisions. Come on.
Well, you should if you can laugh maniacally while you're doing
Right.
it.
Oh, yeah.
That's how it gets done. Yeah, that's what you're doing.
But we can provide, I still think that the strongest merit of science is providing the information that can let people make the good decisions. Will they make good decisions all the time? No, because we're humans and we don't. But that's not a good reason why not to provide the information that could allow people to make these decisions.
So let me land this plane by saying
The stratospheric plane?
let me say every disaster movie begins with people in charge ignoring the advice of scientists. Just saying.
I hear you.
Yeah, that's it.
Daniele Visioni. Grazie.
I love how you say that.
Oh, I love thinking about how to say it. Thanks for joining us here.
Thank you.
Oh my gosh, we loved your expertise, and you
Great
put
stuff.
it in the mix and stir it up and see what comes out the other side. As these years progress, we don't know where the valuation will land.
Oh, we know.
No, stop.
Come on, guys. It's America in 2025. We know. It's America right now.
America. So again, thank you for joining us.
Thank you.
So next up is Holly Jean Buck, Associate Professor of Environment and Sustainability at the University of Buffalo. That's SUNY. That's
nice.
SUNY Buffalo.
SUNY.
Yeah. So ain't that something? When I was growing up, no one would have imagined a department with this title.
That's
Environment and Sustainability.
And that's why we're in this mess that we are in right now.
'Cause
Because nobody envisioned needing this.
Needing this.
Yeah.
I also have her down as Radcliffe Salata, Climate Justice Fellow at Harvard.
Oh, that sounds like a superhero.
That sounds badass.
It really does,
Right.
yes.
Cape and everything. And interdisciplinary environmental social scientist. And with special attention to how people engage with emergent climate control technologies.
Interesting.
That's a thing. That's like a whole sociological thing.
It has to be.
It's got to be. Why not? And my favorite title of them all, author of a book from 2019, After Geoengineering, Climate Tragedy, Repair and Restoration.
Wow. Sounds very much like the movie The Day After.
Or what's that other movie? Snowpiercer.
Snowpiercer.
That was after.
Yeah.
That's where climate people messed up.
Yeah, exactly.
Welcome to StarTalk, Holly.
Thanks so much. It's great to be here.
Do we call you Holly Jean or just Holly?
Either one's great.
Either one's good. Holly Jean's kind of.
Yeah, cool.
Holly Jean.
Holly Jean sounds like a country western star, you know?
Holly Jean.
Holly Jean.
So we've just come off of a conversation looking at the pros and cons of aerosol injections into the atmosphere. Could you just give us some options on how to achieve the same effect that are bandying about today?
The same effect as solar geoengineering.
Yeah, I mean it's got a noble goal to sort of protect Earth from our own misdeeds regarding climate. And so if we don't do that, what are you going to offer us? Did I direct that question to you?
Oh, I'm sorry. Because I had an answer.
Well, there's plan A. Shall we go over plan A?
Well, go.
Please.
Yes.
So a whole bunch of countries, including the U.S. up until a minute ago, but states as well, New York State, have signed on to these net zero targets.
Right.
So ideas
That's
that...
net zero carbon dioxide
Or greenhouse gas.
in general.
I mean, they're a little bit different targets, but yeah, the main idea is you don't put out more than you can remove. And that needs to happen by mid-century, which is actually
yesterday.
really soon. Yeah.
It could have happened yesterday, and
It needs to happen yesterday.
Yeah, and we still got some issues if it would have happened yesterday. But go ahead.
So basically, remaking our whole energy system,
Right.
our built environment. It's a big transformation. That's why people are talking about geoengineering.
All right, so I get that. And this aerosol in the atmosphere solution sounds so Bond villain.
It does sound sexy, doesn't it?
It sounds like this should be in a movie.
Right.
But why not just take the carbon dioxide out of the atmosphere? And they don't have to worry about any of this.
Well, you sound like my mother. You know what you need? You need a sitcom. Why don't you have a sitcom? In other words, go ahead.
We do need to do some of that, but there's a limit at how much we can do. I mean, think about all the effort it took to take it out of the ground, right? All the pipes, all the refining, all the distribution, all of that infrastructure. We're talking about building that basically all over again to put it back underground. So,
and there are limited places where you can actually store
exactly.
CO2.
Yeah.
So
If interesting sort of macro way to see that problem.
That is, yeah. That's a really interesting way to look at it because you never really consider how much infrastructure is involved in just oil extraction and then refinery. Just that. Right. Let alone everything else involved to get it to you where, everything that we see.
I don't have to bury it, do I? For example, the White Cliffs of Dover, that's limestone cliffs, and that's a repository of carbon from our environment. And they're not buried, but not that we're making that, but I'm just saying that didn't involve a pipe to put it back into the ground.
Yeah, so people talk about closed system and open system carbon removal. So in a closed system, you would have an injection well. You'd be injecting that into rock formations deep underground. You more or less know where it is. But what you're just talking about is more of an open system approach, putting it into the ocean, putting it into fields where you can make rocks weather faster. That's a bit trickier because it's harder to measure what's going on.
How are we transporting this? Because you've got certain industries that produce an awful lot of CO2, and then they don't have somewhere right on their doorstep to squirrel this away, I'll call it that. So how are we, pipes are one, are we transporting it in any other way?
Barges, rail, trucks.
The
Ships.
same as oil. The same as oil.
Like
it's exactly the same.
Two trucks go opposite directions on the highway.
They tip each other a tooth.
So that was my soft point.
That's funny.
Yeah.
So if we're spending how many billions on carbon capture plants, right? And I just say to myself,
Are we actually, is that a real thing?
We spent a few billions trying to start them. We'll see if they get
so
finished.
it's still a nascent industry.
Yeah, very much nascent.
Okay.
are they better than trees at capturing CO2?
Oh, that's a very good question, actually.
I love that.
Yeah. Trees are great for a whole bunch of reasons.
Yes.
The thing with these land-based approaches, we need more of them for providing habitat for a million reasons, but we can't expect nature to do all the work here of what we took out of the ground.
Yes, right.
We have limited land for trees, unfortunately, because we want that land for growing food.
And so basically, we should stop eating. That's really
Eating and heating
the
ourselves.
answer here. Stop eating and heating. Eating and heating. Let it go.
So I get many of the land solutions to this, but how about ocean solutions? Other than CO2 just getting absorbed into the water, surely there are creatures out there that would value some uptake in CO2.
If you're talking about the whale concept, that one might not scale to the levels we need it to. But if you're talking about plankton, on the other hand, that seems more promising. These are really early stages of research, though.
But the theory seems really positive. So
How does it work?
Yeah.
What's the procedure?
Basically, the concept of ocean iron fertilization would be to add nutrients to the ocean to create a big plankton bloom. The plankton falls down to the bottom of the ocean.
What do plankton blooms have anything to do with CO2? Or are these the photosynthetic plankton?
Yeah, yeah.
Oh,
yeah.
like a tree.
Like a
They're doing what a plant would do.
Right.
Yeah, exactly.
Oh, okay.
the light bulb went on.
Yeah, thank you. Thank you. So it's an LED light bulb.
I would expect nothing less.
Thank you. So you're growing plankton in the presence of the CO2, no differently how you would grow trees in the presence of CO2, except oceans are huge. So what happens when the plankton die and then they fall to the bottom? Then what?
Ideally, that CO2 would stay at the bottom. But this is the issue with this category of approaches, is that the science is really early and the science is expensive, right? Because you need ocean chartered vehicles going out there doing experiments. And we just haven't really begun that process in earnest.
It's not a laboratory
Right.
experiment.
But the potential for this sink and die of the phytoplankton is capturing massive amounts of CO2. But surely that has some toxicity in the ecosystem.
Yeah, what does it do with oxygen?
Right,
And,
exactly.
there's little creatures down there that they do matter. I care about them.
What was the little microscopic creature that was here that put all the oxygen in the air?
Oh, yeah, cyanobacteria.
Cyanobacteria,
yeah,
right? Yeah, so
Yeah.
there are consequences that happen when you do this kind of stuff.
Yeah, but they would absorb CO2 and release oxygen. So what's so bad about that?
For ocean life,
What do you have against oxygen? What kind of a person are you?
remember I'm a sociologist.
Okay, no, we get it.
It's this lack of joined up thinking that's got us in this situation in the first place. So surely we've got to look at the effect of every living thing in any environment we go into. But the problem is we need to explore, we need to research further, and it doesn't look as if there's a desire or possibly the finances to do it. Or am I wrong?
It's just short of what's needed to really get into some of these questions.
All right, so if you're not a sociologist of plankton, you'd be a sociologist of people. So how do the effects of all these efforts land differently around the world, either economically or geographically?
Well, the rest of the world is ripping us off. That's the first thing. And it's time for us to make sure that we have dominance, the kind of dominance that comes from drill, baby drill.
Thank you, Chuck.
Chew on the nose. No, I mean, there's a couple of issues here. One is that unless people grasp the climate change, the energy transition, the situation we're in, talking to them about these ideas is probably not going to land very well, because if you don't know why we would try it in the first place, right? So,
but there are countries who have nowhere near the resources to participate in this, so they would be passive observers, possibly even victims of our efforts or our folly.
And oddly enough, those countries are far more amenable to the solutions that we need to enact in order to solve this problem. You would think that from what you said that they would be the ones who would be most skeptical. They're not. We're the frickin' problem.
Was that right?
Yeah.
Okay.
yeah, we actually do have some research that colleagues of mine have done in several different countries trying to learn about people's perceptions. And they did find more support for countries in the global south, countries that are facing a lot of climate impacts right now. But I would caution that most people haven't heard anything about any of these approaches. So what somebody hears in a survey or initially is going to be shaped by what people say about it, other messengers, their friends and family, once they start to discuss it with other people.
Which is, I think it was this year's Yale report, that still it's somewhere around upwards 53% of people say they rarely or never talk about climate change with friends or family. That's this year's report.
Not even a thing.
So we're just not even discussing it at all. We're la la la.
So right now, this little group here are outliers.
Yes.
Wait. So how do we then think about the social consequences or ethical issues of this down the line? How do you handle that?
I mean, I think the first step is just to involve more people in the conversation.
Okay.
And that can be done a lot of ways.
Which
it can
hardly
be
ever
done.
happens. So
Yeah.
you need agencies or organizations that'll do that.
Yeah, you need actually dedicated staff to work on it. It's a big challenge.
So who's the most important voices that need to be heard in regards of this?
Her voice.
No, not my voice.
Lean into the microphone. My voice. Go.
But do
Okay.
it ASMR.
It's my voice. Yes. Holly Jean is speaking.
Is it the powerful, rich Western nations, or is it the global South? Is it African nations? Is there a demographic or group?
Well, everybody has a stake, and everybody needs to do something with climate and energy, right? Nobody can sit by.
Yeah, nobody's getting out of this one.
No, that's
So what of all the options that you've seen, what horse would you bet on as the most effective but also most humane, if I may?
I think we need to triple nuclear capacity. We have a goal about that, or we did. I hope we keep doing that. We need abundant clean energy for people because a lot of people don't have access to energy, and
So
that's
this
part
might
of it.
turn the tables on the anti-nuke movement that had been so strong over the decades.
I hope so. We've seen public sentiment on that shift pretty quickly, actually.
So that's the show we had with Catherine Huff on the small modular reactors.
Right, because the nuclear reactors can be scaled and they can be built anywhere you need them, right?
I don't think they're at the point where they can commercially put them in, although we've had nuclear reactors in submarines
Oh, yeah.
for some time. So there must be some way to scale it and make it practical.
Oh, yeah, completely. Completely. Plus, there's not as much spoken of how dependent France has been on nuclear power for decades. And it's not even a thing.
Right.
They'll protest anything at any time of day.
Except smoking.
I give you a true example about France's nuclear program. I have to say nuclear.
Would you
Thank you
stop
for
giving France cancer every time you're imitating a French person?
They put a nuclear power plant on the northwest coast of France, closer to London than it was to Paris. That's how much the French love the Brits.
Okay.
So is there going to be a mistake that we make in our attempts to do the right thing? What are we most likely going to get wrong?
I mean, you can see a lot of problems considering that we're dismantling our capacity to even monitor what's going on in terms of, attacks on science and government. Yeah. So, there's tons of risks. All the people who are concerned, I share their concern.
Okay, give us something positive here, please. Tell us, what are you hopeful for?
Well, I think that public thinking about this can and will shift. The question is one of timing. That's why we're talking about geoengineering.
Yeah, but you would know better than others what would help make that shift. What kind of forces need to be in play to change an attitude or a perspective?
Has there been something in history that you're familiar with where a public sea change of opinion has happened for the better? Because that's kind of the shift that we need to have for this, or at least here in America.
Some of the examples people point to are the civil rights movement, gay marriage, these social things. I think it's a little bit trickier when you're talking about reconfiguring the built environment. But the mindset has to happen first.
How about we get ahead of the story? There seems to be a fair bit of misinformation regarding climate, global warming.
Or disinformation.
But that's exactly it.
Yeah,
so there's this disinformation. Mm-hmm. How about we get ahead of that narrative and start to put out real, solid, strong, and take that 53% and make it much, much bigger?
I mean, you asked me about technologies and I said nuclear, but we have to also shift the framing into investing in social infrastructure, investing in people. And I think that because we have an administration that's backing away from that, that's crashing our social infrastructure, people are going to recognize the value in the relationships, the agencies, functioning government, and will build that capacity to, when we do have the political will to build these new technologies, we'll have the social will that matches it.
Not to put words in your mouth, but are you saying that the dismantling of these social structures, these social institutions, may awaken people to their need in ways that they had previously taken for granted?
Yeah, we had a problem even before Trump, where we passed all this money in the U.S. for climate and energy projects, and we couldn't get it spent fast enough because we didn't have enough people in the agencies to spend it, to review it, to even hear about the grants. People on the ground didn't know. And now people are realizing you need people to do this. It's not just about investing in tech.
So what I was going to say is it takes money. It actually takes money to spend money. It takes money to educate people. And how do you combat the other side, which is disinformation? Fossil fuel companies, through their so-called outlets and foundations, right? Mm-hmm. They spent $900 million that was tracked last year. $900 million on disinformation. So we got to come up against that, So that's a serious thing.
But and we got to land this plane real quick. But presumably, if you ask them, they wouldn't say it was disinformation. They would just say it's information. So what you really have to do is empower the listener to know the difference. From a sociological perspective, how do you do that?
Yeah, you don't go to people and say you're misinformed, because then it's like you're saying, well, you're dumb. You didn't know the right information.
No. So that's my problem.
I've been an idiot. Oh,
Jesus.
No. Right. You give them information that's grounded in science, and you say they're really hard trade-offs, but you have choices. It's important that you don't make people feel like all of this stuff is going to take away their freedom. That's what they're worried about. Saying,
we do such a good job.
We need to start calling electricity Liberty Juice. Liberty Juice. Liberty Juice.
We need a focus group.
You want to save America, what you got to do is get a car that runs on Liberty Juice.
All right, this thought experiment.
That's pretty good, Chuck. I think that's
the answers are out there.
Yeah. Say we fall on a technology that is practical, cost-effective, give or take, and we do get ourselves to these pre-industrial zero levels. Will we not think, well, it doesn't matter, we can burn all the fossil fuels we want because we can control it now?
You okay with that?
That's a big argument, yeah, man.
Yeah.
Yeah.
Is that likely to happen for us? Because we've driven ourselves at speed.
If we become
here.
good at it, then drill, baby, drill. Who cares?
I just think burning rocks is kind of archaic. Like, I just think we can do better. I mean, whatever. I think we can come out with something that outcompetes that. And
Okay,
also,
so you win economically then, and then the economics drives it.
But do we not,
Not
as a
sentiment.
species, do that thing anyway, where we tie our own shoelaces together or find a way to shoot ourselves in the foot?
Speak for yourself, dude.
I was.
I was. That was good. Well, I think the danger that many people see is that once you have anything that's viable on a geoengineering scale, which we're nowhere near, by the way, but once you do, that fossil fuel companies will then use that as a cudgel to say, we can keep burning fuel. You know, so a lot of people
And
are like...
that's my concern.
Yeah, a lot of people are like...
You foresee that, presumably.
Yeah, I wrote a book called Ending Fossil Fuels that was about the challenge of how you end fossil fuels, and the geopolitics of it are really tough because some countries really depend on this for their revenue and their legitimacy. And I could see them saying, well, let's keep on going.
So countries like Venezuela or Qatar or
Russia.
Yeah.
Yeah, these are all the countries.
Yeah, so it's a whole other thing. Here we're saying, stop burning fossil fuel, and you'll bankrupt the country.
Yeah.
They built their whole economy on it.
Yeah.
Unless we're willing to make massive transfers of finance, which we apparently aren't.
Yeah.
Well, then that becomes your problem as a sociologist.
I'll take all the problems.
You fix it.
A lot of work.
Well, Professor Buck, thank you for being on StarTalk.
Yeah.
Delighted to have you on the Asimov panel, and that you guys kidnapped her for StarTalk. Very good job here.
Thank you.
Thanks so much.
And just so you know how deeply I respect your profession, my father's a sociologist, and I was actually received a sociology award from Congress. I think they appreciated how much I always tried to think about the impact of science on people, and I was very moved by that. And so I wish you well.
Thank you.
And maybe some luck, because we might need some of that too, based on how stuff goes down with the human interaction function that's out there.
Yeah, we're screwed.
Thank you, Chuck, for that concluding. So, Holly, Chuck, Gary,
Pleasure.
always good.
Always a
Thank you.
pleasure.
This has been another edition of StarTalk Special Edition. Geoengineering. The good, the bad, the ugly. Until next time, Neil deGrasse Tyson. Keep looking up.